So starting off today, we're going to move into section 2, oxidation numbers. So what is an oxidation number? It is a positive or negative number, so positive or negative, assigned to an atom to help us see its degree of oxidation or reduction. So for ions, the charge is the oxidation number. So we've been talking here in the last lesson, we looked at what charge does the ion have to help us determine did it gain or lose electrons. But if we're talking about covalent bonds, then we're talking about a whole different situation. The idea here of an oxidation number is if all of the electrons in the bond were assigned to a more electronegative element, what would happen to the electrons? Would it gain or lose electrons? So that's really the idea. So it's kind of like assigning charge in a covalent bond, but not really. In ions, as we said just a minute ago, oxidation number is the charge. When we write oxidation number, the sign is always put before the number. Often when we talk about charge, we show that the charge would be, as in sodium, 1 plus and chloride 1 minus. But when we talk about oxidation numbers, we say plus 1 and minus 1. So here's how things would work in a molecular compound. We would look at a bond, say between hydrogen and oxygen. In a bond between hydrogen and oxygen, thinking about that bond, we know a bond is 2 shared electrons. That in a bond, the electrons get shifted toward the oxygen because oxygen is more electronegative. So we would assign oxygen its oxidation number of something, like we would say it's -2, and hydrogen is a +1. So oxygen gets more than its share of the electrons in this bonding situation. So it's like assigning charge, even though it's really a molecular compound and the electrons are shared. When we write oxidation numbers, we write them above the formula, and oxidation numbers are assigned by individual atoms. Even though there are actually 2 hydrogens in this compound, we say that each hydrogen has a +1 oxidation number. So each individual atom is what that number is assigned to, not both of them together. So we have some rules that we apply to assign oxidation numbers. So the first rule is the oxidation number of a monatomic ion is equal to the charge. So that's the first rule, and we talked about that rule already. So if it's a monatomic ion, like just a bromide ion or just an iron ion, the oxidation number is equal to its charge. Rule number 2. Hydrogen is +1, but there is an exception to the rule when hydrogen bonds to a metal, it is -1. So hydrogen is +1, except when it's a metal, it's -1. Oxygen is -2. Almost always. There are 2 exceptions. The exceptions for oxygen are in a peroxide, like H2O2, it's -1. And with fluorine, oxygen is a positive charge. Fluorine is the most electronegative element, so it's kind of like the electron bully. So fluorine gets its negative charge, it gets its electrons, and oxygen just says, okay, whatever, I'll be positive if you make me. All right, so if it's with fluorine, fluorine takes precedence. The next rule is the oxidation number of an element, a pure element, is 0. When it's not bonded to anything else in its natural state, the oxidation number is 0. The last 2 rules have to do with the idea of neutral compounds and ions. So in a neutral compound, all of the oxidation numbers add up to 0. If you have a polyatomic ion all by itself, the sum of the oxidation numbers equals the charge of the ion. So if it's neutral, the oxidation numbers add up to 0. If it's a polyatomic ion, the oxidation numbers equal the charge. Now, you might ask, what about all of the other elements? Nitrogen, sulfur, carbon, phosphorus. What about those elements when they're in a covalent bond? What about them? Well, they take whatever's left.
What does number 6 equal?
So here's some examples. Here's a reaction, a copper wire placed into a solution of silver nitrate. So we have silver nitrate here reacting with copper to form copper nitrate and silver ions. But when we see the, before we may have called that a single replacement reaction, but here we see that silver is going from a +1 charge to an ion to a 0, and copper is going from a 0 to a +2 charge. So there's our oxidation and our reduction. But the numbers that we're really looking for is how do we come up with these numbers? All right, so initially we look at, here's a compound like H2CO3. So how do we assign the numbers? Well, look at your rules. Do we have anything that applies in those rules, right? I don't have any neutral elements. I do have hydrogen. Is hydrogen bonded to a metal or not? No. So if it's not bonded to a metal, what's its charge? Its oxidation number. So it's +1, right? I don't have any rules about carbon, but I do have a rule about oxygen. Oxygen is a -2. So now I have to figure out what's left for carbon to have, right? Because this is a neutral compound, so the sum of the oxidation numbers has to equal 0. So for hydrogen, I have +1, and there's 2 of them. And then there's something for carbon. And then oxygen is -2, and there's 3 of them. So all of the oxidation numbers have to add up to be 0. So I have +1 times 2, so that's a +2, and oxygen makes -6. So what's left for carbon? How do I get to 0? Carbon is +4.